a lesson, Intro to Proofs. Wednesday before, we talked about algebraic proofs. And so, when I first looked at this book, they crammed all of that into one lesson, and they didn't really give you very many examples. So I kind of spread it out to help explain it, hopefully a little bit better to you. And so today we're going to cover more that's actually in our lesson 1.7. But before we get started into that, there's a few things that I want to review. The first thing is the segment addition postulate. We talked about it and the angle addition postulate earlier on in the first part of this chapter. And remember, the segment addition postulate says that A, B, and C are collinear, and B is between A and C if and only if AB plus BC equals AC. Okay, so what that's telling me is that you have these three collinear points where B is between A and C. And it says if you add those two smaller parts together, it's going to equal the whole. Okay, remember that's segment addition postulate. And we have angle addition postulate. And it says that if D is in the interior of angle ABC, then again, if you add those two smaller angles together, it will equal the entire angle. So the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Okay? So those are going to come into play a little bit today. In the last couple of days, we talked about congruence. Okay? And the definition of congruence says if segments or angles, either one, are congruent if and only if they have the same measure. So basically what that tells me is that if I have two segments or angles that are congruent, then those two segments or angles are also equal. And you can go back and forth between congruence and equality by the definition of congruent segments or angles. Okay? Now, why does it matter? You have to be in the equality mode in order to substitute, in order to add, subtract, multiply, divide, distribute. Okay? To do any of those algebra things, you have to be in the equality mode. Okay? In the congruence mode, you can't do that, but you can still use transitive and symmetric and reflexive and some other things that we'll learn. Okay? So, if you're going to do any algebra, any math, you've got to go from congruence to equality before you can do that. Alright, so let's look at this first problem right here. It says that PR equals QS. So it's telling you that this segment right here, PR, and this segment right here, QS, their measures are equal to each other. I want to prove that these smaller segments, PQ and RS, are equal to each other. Okay? Now, it kind of makes sense that they would, because since they overlap each other, if I got rid of what they had in common, wouldn't what's left be equal to each other? Okay, yes. So, that's what we're going to do to set forth our proof here. Alright, so the first thing that we do is we state the given PR equals QS. That's a given. Now, because I know that those two big parts are equal to each other, I'm going to establish what makes those big parts up. Okay, so, what makes up PR? Well, PR is made up of PQ plus QR. And QS is made up of QR plus RS. Okay? And that is the segment addition postulate we talked about at the very beginning. Alright, now, what we're going to do is we notice that PR and QS are equal to each other. See how these two little pieces right here are equal to each other? If these two are equal to each other, then the sum of their parts are going to be equal to each other, yes? It's like taking this PQ plus QR and replacing the PR with it. It's taking the QR plus RS and replacing the QS with it. So, we have, let's say, plus QR equal to QR plus RS. What do you think that would be called? I heard somebody say something. Substitution. Okay. They might call it, speaking of substitution, they might call it transitive. I would take either one. Okay. All right. Now, remember, I'm trying to get EQ and RS to be equal to each other. Yes. Okay. We're going to subtract QR from both sides. All right. So if I do that, these go away. I end up with EQ equals RS by subtraction. So I started out with my given. Those were the bigger segments. I showed what made them up by the segment addition postulate. Then I realized that the sum of the parts are equal to each other, just like the big parts are. So I set them equal to each other by substitution, and then I subtract what they had in common. Okay. Now, a couple of theorems that we've already talked about what they say, we just didn't give them a name. The first one is the vertical angles theorem. And it says that vertical angles are congruent. We already knew that, right? Okay. But it is a theorem. And a theorem is a conjecture that is proven by some kind of proof. Okay? And so sometimes they give these theorems names, sometimes they don't. Alright? But this one is called the vertical angles theorem. The other theorem here is the linear pairs theorem. And it says that if two angles form a linear pair, then their sum is 180 degrees. So that, and we talked about that also. Alright? So, if you see that you have a linear pair, or and you can say they add together to equal 180 by the linear pairs theorem. If you see you have vertical angles, then you can set them congruent to each other because of the vertical angles theorem. Okay? So those are some reasons, and they're on that pink sheet that I gave you. Okay? Alright. Now, like I said, a theorem is something that's proven true. So what I'm going to do is I am going to prove to you the vertical angles theorem. Now, I won't make you prove every theorem that we learn, but I want you to see how a theorem is derived. If there was some mathematician one day that was looking at something and said, hey, I know that I can see that these vertical angles are congruent. But before we can accept his information as fact, he has to be able to prove it to us. Okay? So I'm going to show you how you go about doing this. So we have a picture here, and you're told that angle 1 and angle 2 are vertical. I'm going to prove that angle 1 and angle 2 are congruent. Alright? And so we're going to use a proof, two-column proof in this case. We've already kind of talked about this a little bit. Alright, so we start out with angle 1 and angle 2 are vertical angles. And that's given. Now, I can't just go to the proof. Even though we know that's true, I have to show why it's true. Okay? Alright. So, the next thing that I'm going to do is I am going to notice what other kind of angles I have. What other kind of angles do I have going on there? What? Well, yes, I have acute and I have obtuse. Yes, but what other kind of angle pairs? Let me say angle pairs. I have what? I have some linear pairs, right? 1 and 3 are a linear pair, right? And 2 and 3 are a linear pair, yes? And the linear pairs theorem told us if we have linear pairs, what's true about it? They add up to equal 180. Okay, so I'm going to write that down. I'm going to say, okay, well, the measure of angle 1 plus the measure of angle 3 equals 180. And I'm going to say the same thing about the measure of angle 2 plus the measure of angle 3. It also equals 180. And what's my reason for that? Okay, linear pairs theorem. Okay, linear pairs theorem. Now, I see that those two sums both equal 180. And if those two sums both equal 180, could I set the sums equal to each other? Yes, that's equal to the same thing. So I can say now that the measure of angle 1 plus the measure of angle 3 equals the measure of the measure of angle 3. What would that be called? Transitive substitution. I would do either one. Either one. You don't have to put both. Either one I would say. Okay, now remember, we're trying to get 1 and 2 to be congruent. Alright, so what's going to have to happen here? I got to subtract angle 3 from both sides. So that gives me the measure of angle 1 equals the measure of angle 2 by subtraction. Okay? And so I'm almost there. Now what do I have to do? Change it to congruent. So angle 1 is congruent to angle 2, and that's definition of congruence. Congruent angles in this case, the congruence is fine. Okay? So we have proved the vertical angles theorem. Okay? And so now we don't have to go about this proof, we can just use it. Alright? It's proven to us. And you can use the linear pairs theorem. Okay, once I give you a theorem, unless I ask you to prove it, then you can just use it in a proof. Okay? Alright, now, I did this one with my last Archimedes photo. Okay? So, I am going to explain it to you, but I already have it written down. And I will give you time to write it down in a minute. But I want you to put your pencil down, I want you to just watch first. Okay? Because there's a lot to it. Where you see all those letters. Okay? Alright. In this problem, we're given that BD bisects angle CBE. Okay? So, this right here, BD bisects CBE. What can we get from that? CBD and CBE are congruent, right? Okay. Now, what are we trying to prove? This angle ABD, okay, and this angle SBD are congruent to each other. Okay? We're trying to prove that the yellow and the green are congruent to each other. Okay? So, we know that these two are congruent. Okay? Now, when you do a proof, I always tell people, look for linear pairs, because you know information about that, and look for vertical angles. Okay? Do you see either one that might be helpful? I see both, but what's going to be more helpful? The vertical angles, right? Okay, so I'm going to say that this angle here and this angle here are congruent. Okay? Now, let's think about this. If these two smaller angles are congruent and these bigger vertical angles are congruent, would it not make sense that I could add the little one plus the big one is going to be equal to the little one plus the big one? Yes, okay? And so really, that's what we need to do. Now, how do you set that up? Okay, so you start out with your given, like I did, okay? Then I stated these two little ones were equal. Okay, that's what I did right here as my second step. Okay, angle CBD is equal to angle BD, definition of bisect. Then I went to the bigger angles, and they're vertical. So I said that they are congruent by the vertical angles theorem. Okay? Alright. Now, since we're going to be doing some adding and whatnot, some substitution probably, I need to be in equality mode. So what I did is I took these two right here and I changed it to equality statements. So that's what I did. I took this, I changed it to equals, and I changed this one to equals, okay, by the definition of congruence. Alright, now, here where it gets a little different, okay? Alright, so, in this next step, I used addition. And when I say I used addition, I took the bigger angle, ABC and SBE, okay? Those are the two bigger angles that are equal, and I added the smaller ones to both of them. So I took the purple and I added the yellow, okay? You see what I did? These two purple are equal, the two yellow are equal. So I added yellow to one side and yellow to the other. Okay, so I added the two together. And I'm adding the same thing to both sides, so I use the addition problem. Okay? Alright. Then what I had to do, this is kind of a technicality. Then what I had to do, instead of the two parts added together, I want the whole. So what I had to do is I had to come over here to my green angle ABD, and I had to show what makes that up, which is ABC plus CBD. And then I had to go to my yellow angle, and I had to show what makes it up, okay? And then what I did is I realized that I can replace this ABC plus CBD with ABD. And I can replace SBD plus DBD with this bigger angle SBD. That's substitution or transfer. Either one. Okay. Probably transfer according to our right? And then we change it back to the congruent state. Okay? Now that's a lot. Alright? I'm not going to ask you to do that on your homework. Alright? I want you to show I want to show you how it's done. Now, I'm going to give you time at the end to go back and write this down. Alright? Because I don't want to waste our class time doing that. Alright? Okay. So, does it kind of make sense? A little bit? Okay? I know it would be hard to do all by yourself, but we'll hopefully get to that point. Okay? Alright. I want to use it again next time. I want to write about it. Okay. Now, a couple of other theorems. Okay? We have the congruent supplements theorem, and we have the congruent complements theorem. And just FYI, today, we're going to work on this assignment tomorrow, too. Okay? So it's going to take most of the hour for me to finish this, but we will have time tomorrow in class to work all out. Okay? All right. Okay. So the congruent supplements theorem says if two angles are supplementary to congruent angles or to the same angle, then they are congruent. So basically what that's saying is that if 1 and 2 are supplementary and 2 and 3 are supplementary, see how 1 and 3 are both supplementary to 2. If they're both supplementary to the same angle, then they should be congruent to each other. Okay? So, like, let's say this was 60 and this was 120, and this was 60 and this was 120. See how they're both supplementary to the 120 degree angle? Then they're going to be congruent to each other. Okay? And it would be true if I had another angle here, 4, and I said that 1 and 2 were supplementary, and 3 and 4 were supplementary, and if 2 and 4 were both 120, then these two would have to be the same. Okay? So it works with the same angle or a pair of congruent angles. The same holds true with the congruent complements theorem. Okay? And basically the same thing. If two angles are complementary to congruent angles or the same angle, then they're congruent. So again, if 1 and 2 are complementary and 3 and 2 are complementary, well, then 1 and 3 are both complementary to 2. That means 1 and 2 added together equal 90, and 3 and 2 added together equal 90. If they're both complementary to 2, then what should be true about 1 and 3? Then they're the same, right? Okay, so congruent complements, congruent supplements. Okay. Alright, this next one is a proof of the congruent supplements theorem. Okay, so again, and this is what's called a paragraph proof. A paragraph proof is a little less formal than a 2-column. It's basically the same idea, except it's in a different format. You just put it in a paragraph form. Okay? I really like the look of the 2-column proof, but a lot of things in math are done in a paragraph. Okay, so by definition, you're given that 1 and 2 are supplementary and 2 and 3 are supplementary. That's it. Okay? By the definition of supplementary angles, 1 plus 2 equals 180. And 2 plus 3 equals 180. Right? That's what we get when we have supplementary. Since both sums equal 180, then I can set 1 plus 2 equal to 2 plus 3, kind of like we did in that problem earlier. If I subtract 2 from both sides, I get 1 is equal to 3, and then I can change it to 1 being congruent to 3. Okay? So again, this is a proof of a theorem called the congruent supplements theorem. Remember, every theorem has a proof to back it up. Now, you can use the congruent supplements theorem, you can use the congruent complements theorem, and you don't have to prove it. Okay? But that's how those mathematicians back in the day were able to prove it to us today. Okay? Alright, a couple of other things. All right angles are congruent. Why are all right angles congruent? Well, there is a box there, but why are they congruent? They all equal 90 degrees. Any angles that have the same measure are congruent, right? Okay, I'm sorry, you may have said that. boxing, that's the first thing I heard. Okay, here's another proof, or another theorem. These don't have names, okay? And so if you use these in a proof, you can't use the theorem number because it doesn't match up universally. You have to actually write the theorem out. Now you don't have to put the commas and the periods and everything exactly. You can summarize it, but anyway, you have to write it out. You can't just use theorem 1.5. All right, if two angles are congruent and supplementary, and each is a right angle. Okay, so let's think about that. What does it mean to be congruent, the same, and supplementary equals 180? So if you have two angles that are the same, and they add together to equal 180, what's your only choice? 90. And if they're 90, they are right. They're right. Yes? Okay. So, all right. Last one, I believe. This one's not too hard. And I'm not, when I did this last hour, I didn't use all the lines. Okay. This one tells us that angle 1 and angle 2 are equal to each other. So angle 1 and angle 2 are equal to each other. It says that angle 1 is 105. We want to prove that angle 3 is 75. Okay? Alright, so let's write our given. Measure of angle 1 equals the measure of angle 2. And the measure of angle 1 equals 105. And that is given. Okay. Alright. So, I'm given that information. I somehow have to make a connection with 3. Okay, does 3 have a relationship with anything? Well, 1 and 2 are not a linear pair. 1 and 2 are congruent. 2 and 3 are a linear pair, right? And if 2 and 3, you're good, that's the point. If 2 and 3 are a linear pair, what do we know about? They equal 180. Alright? So we're going to say that the measure of angle 2 plus the measure of angle 3 equals 180. And what's that reason? Linear pairs theorem. I'm all about abbreviations as long as we all know what we're talking about, okay? Alright, so that's a linear pairs theorem. Alright, now, back up here, we know that the measure of angle 1 equals the measure of angle 2. And the measure of angle 1 is 105. What does that tell me about the measure of angle 2? Okay, so the measure of angle 2 equals 105. What would that be called? Substitution, okay? Alright? Okay, so if the measure of angle 2 is 105, can I go into my step 2 and replace 2 with 105? Okay, so 105 plus the measure of angle 3 equals 180. And that again would be what? Substitution. Okay? So then what should I do? Subtract the 105 from both sides. So that gives me the measure of angle 3 equals 75. And that would be what? Subtraction, right? I'm done, right? That's all I need to do. Yeah, that's all I got to do. Okay? Alright, questions. I know that you might be like, oh my, this is crazy. Okay? But please know that, first of all, this assignment I give you, I do not expect you to take it home and finish it all tonight. Do not go home and spend 3 hours on it and say this bit is neat and I hate geometry. Okay? You can take it home and you can work on some of it. Try to get a few things done. Get stuff and put it away and we'll work on it in class tomorrow. Alright? Okay? But I would try to get some of, maybe 5, 6 problems done